Hello students, in this video today I'll discuss about chemical equation. Chemical equation. So first you have to know what is a chemical equation. Chemical equation is the symbolic representation of a chemical reaction. Symbolic representation of a chemical reaction. The representation of a chemical reaction in symbolic form using symbols of reactant and products. Using the symbols and formula of reactant and products is known as a chemical equation. And when the chemical equation, when the chemical reaction is represented using the name of the reactant and product involved in the chemical reaction, then the representation is known as word equation. Okay. So representation of a chemical reaction using the name of the chemicals, name of the reactant and product involved in the chemical reaction is known as word equation, but the symbolic representation of the chemical reaction using the symbols of reactant and products is known as chemical equation. Okay. Now I'll tell how to write the word equation of a chemical reaction. Okay, how to write the word equation. Writing a word equation, you have to follow some steps. So first step or first rule, you have to follow these rules to write down the word equation of a chemical reaction. A word equation has two parts, left hand side and right hand side. An arrow separates the two parts. The reactants are written on the left hand side of the arrow, and the products are written on the right hand side. Okay, and the reactants and products are separated by an arrow. Okay, you have to write reactants on left hand side and products on right hand side. Okay, now second rule, in case there are more than one reactant, if more than one reactants are present in the chemical reaction, then you have to give a plus sign between two reactant. Okay, so in case there are more than one reactants, they are separated by a plus sign. Similarly, if there are more than one product, they are separated by a plus sign. Okay, so you can write like this: reactant 1 plus reactant 2 plus reactant 3. If three reactants are there, then you can write like this: reactant 1 plus reactant 2 plus reactant 3, arrow product 1 plus product 2 plus product 3 plus product 4, like this. Okay, for example, when carbon react with oxygen, carbon dioxide is formed. Okay, and the word equation for this reaction is carbon plus oxygen, both are reactant. Carbon combine with oxygen to form carbon dioxide, so carbon dioxide is the product. So the word equation is carbon plus oxygen, arrow carbon dioxide. Next rule, the condition of the reaction are usually written on the top of the arrow, top or below the arrow. Okay, generally written on the top of the arrow. The necessary conditions for the reactions are usually written on the top or below the arrow. So reactants arrow, above the arrow or below the arrow, you have to write the reaction conditions and then product. Okay, and now I'll tell how to represent the chemical equation, or how to convert the word equation into chemical equation. Now if you replace the name of the reactant and product with corresponding symbol and formula of the reactant and product, you will get the chemical equation. Okay, so the name of the reactant and product are replaced with this corresponding symbol and formula to get the chemical equation. And the reactant and product must be written as molecules, not as atom. Remember that. You have to write the reactant and product must be written as molecules, not as atom. So the word equation for the reaction between magnesium and oxygen. When magnesium reacts with oxygen, you will get magnesium oxide. So the reaction word equation for this reaction is magnesium plus oxygen, and the reaction condition you have to heat. Okay, when magnesium is heated with oxygen, you will get magnesium oxide. This is the word equation. Now, what is the formula of magnesium? It is Mg. And what is the formula of oxygen molecule? It is O2, not O. Okay, so O2, and magnesium oxide is MgO. Okay, so the chemical equation for this reaction, magnesium plus oxygen to give magnesium oxide, the chemical equation is Mg plus O2 arrow MgO. This is the chemical equation, and this is the word equation. Okay, remember that oxygen molecules means O2, not O. Okay, so incorrect one is given, also given here, Mg plus O. Mg plus O. O is oxygen atom, but you have to write the formula of oxygen molecule, not the formula of oxygen atom. Okay, so this is wrong representation, incorrect representation. Mg plus O arrow MgO. Okay, now see, one point is given, the word equation. The word equation is qualitative in nature. The word equation of a chemical reaction, it is a qualitative, not quantitative. Qualitative in nature. This is because the word equation mentions the reactants and products only, name of the reactant and product. It mentions only the name of the reactant and product, and it says, the word equation says nothing about the quantities of reactant and product. That is why it is a qualitative representation of a chemical reaction. Okay, so in the reaction, Mg plus O2 implies MgO. In this reaction, this is the chemical equation. Now see, in this reaction, the number of atoms on both sides are not equal. On left side one magnesium, on right side one magnesium. Magnesium atoms are equal, but on left side two oxygen atoms. O2 molecules means two oxygen atom, but on right side one oxygen atoms. Okay, so number of atoms on both side of the arrow are not equal. In left hand side there are three atoms, and on right hand side total two atoms. Okay, on left hand side total three atoms, one magnesium and two oxygen, and on right side at side of the arrow there are total two atoms, one magnesium and one oxygen. Okay, so one oxygen atom seems to be destroyed in this equation. Okay, and this representation violates the law of conservation of mass. Okay, violates violates the law of conservation of mass, that says atoms are neither created nor destroyed in a chemical reaction. Okay, the law of conservation of mass states that atoms are neither created nor destroyed in a chemical reaction. But in this reaction, in this chemical equation, you can see one oxygen atom seems to be destroyed. Okay, so this type of chemical equation is called unbalanced chemical equation or skeletal equation. So this chemical reaction equation is unbalanced chemical equation or skeletal equation. Okay, so you have to balance the chemical equation, otherwise the chemical equation violates the law of conservation of mass. But how to balance the chemical equation, it is not given in your syllabus. In class 8 you will study about how to balance a chemical equation. Okay, so balancing process you will study in class 8. Okay, but for this reaction the balance equation is 2Mg plus O2 implies 2MgO. You have to write 2 in front of Mg and 2 in front of MgO to balance the chemical equation. Okay, Balancing, it is given in class 8. Okay, now see some solved examples are given for some chemical reaction. First one is burning of carbon. Huh? Burning of carbon means reaction between carbon and oxygen. Burning means reaction with oxygen. Okay, so the word it is a combination reaction. Combination reaction, carbon directly combined with oxygen to give carbon dioxide. So the word equation is carbon plus oxygen to give carbon dioxide. Okay, the chemical equation is C plus O2 implies CO2. Second type of reaction is second example, reaction between hydrogen and oxygen, H2 plus O2. It is also combination reaction. It is also combination reaction. Okay, hydrogen, that is H2, combined with oxygen, that is O2, to give water. Water means H2O. So the chemical equation is H2 plus O2 implies H2O. Okay. Next example is reaction between hydrogen, but this reaction H2 plus O2 implies H2O. This is unbalanced chemical equation. Okay, this is skeletal equation, not the balanced one. Okay, after balancing, the equation becomes 2H2 plus O2 implies 2H2. Okay, that is, you have to multiply H2 by 2 and water by 2 also to balance the chemical equation. To make the number of atoms on both sides of the arrow equal, you have to uh, write 2 in front of H2 and 2 in front of H2O in this equation. Third example, reaction between hydrogen and chlorine, that is H2 plus Cl2. This is also combination reaction. Okay, H2 plus Cl2 implies HCl. This is unbalanced, and the balanced chemical equation is H2 plus Cl2 implies 2HCl. Next example, reaction between iron and sulfur. This is also combination reaction. Iron means Fe and sulfur means S. So Fe plus S, arrow above arrow, you have to write the reaction condition, that is heat. Fe plus S implies FeS. This is balanced one. Okay. Reaction between carbon dioxide and water to give carbonic acid. So carbon dioxide plus water, it is also combination reaction, implies carbonic acid H2CO3. CO2 plus H2O implies H2CO3. Next, electrolysis of water. Electrolysis of water. So when electricity is passed through water, water decomposes to give hydrogen and oxygen gas. This is a decomposition reaction. Water decomposes to give hydrogen and oxygen gas when electricity is passed through water. So the word equation is water, arrow, above arrow you have to write the reaction condition, that is electric current, above arrow electric current, and the products are hydrogen and oxygen. The chemical equation is H2O, arrow, H2 plus O2. This is unbalanced or skeletal equation. So the balanced chemical equation is 2H2O, arrow, above arrow electric current, then 2H2 plus O2. This is the balanced chemical equation. Next example is heating of heating limestone strongly. Heating of limestone. Okay, limestone means CaCO3. Calcium carbonate is known as limestone. Okay, when limestone is heated, you will get calcium oxide and carbon dioxide. Okay, the chemical equation is CaCO3, arrow, above arrow you have to write heat, CaO plus CO2. CaCO3 means limestone, calcium carbonate. Heating of potassium chlorate to give potassium chloride and oxygen. Potassium chloride and oxygen. So when potassium chlorate, that is KClO3, is heated, you will get calcium oxide, potassium chloride, KCl, and oxygen, O2. The chemical equation is, balanced chemical equation is 2KClO3, arrow, 2KCl plus 3O2. Okay. And electricity, passing electric current through molten sodium chloride. Sodium chloride decompose to give sodium and chlorine gas. Sodium metal and chlorine gas. This is also decomposition reaction. NaCl, electric current, arrow, Na and Cl2. This is decomposition reaction. And last example is passing electric current through molten lead bromide PbBr2. When electric current is passed through molten lead bromide decompose to give lead and bromine gas. Okay, so PbBr2 arrow Pb plus Br2. And this chapter is completed. Thank you, students.